So atoms of the same element always have the same number of protons, and therefore they'll have the same atomic mass as well. But atoms of the same element can have different numbers of neutrons, and these are known as isotopes. So that if for hydrogen, there are 3 isotopes. So the most common one is called protium. So this is a hydrogen atom with 1 proton and 0 neutrons. And 99.98% of all hydrogen atoms are protium. And it's used in hydrogen fuel cells and also the production of plastics. Second isotope of hydrogen we're going to look at is called deuterium. So deuterium is a hydrogen with 1 proton and 1 neutron. So this, remember, it's got the same number of protons, but it's got a different number of neutrons. And around 0.02% of hydrogen atoms are deuterium. And it's used for nuclear fission for the creation of energy. Third hydrogen isotope is tritium, and that has 1 proton and 2 neutrons. And it's very rare, but it can be used in the thermonuclear fusion weapons, so what we know as nuclear weapons. So how many isotopes of hydrogen are there? Now remember, there are 3. And those 3 are protium, deuterium, and tritium. Now the relative atomic mass, which we can say is the AR, R with a little r, a small r just below the A, is the average mass of all the isotopes of an element. It takes into account how often each isotope is found, which we call the isotope abundance. And when we calculate the relative atomic mass, we can use the expression of the sum of each isotope abundance times by the isotope mass number, all divided by the sum of the different isotope abundances. So if you think of this in an example, 75% of chlorine atoms have a mass number of 35, while the remaining 25% have a mass number of 37. So if you ask the question, what is the relative atomic mass of chlorine? Well, you'd take 75% times by 35 plus 25% of 37. And you divide that by the 100% that would give you. So the overall relative atomic mass of chlorine in this example is 35.5. And if you, just to recap that, so 75 times by 35 plus 35, plus, say that again, 75 plus 35 plus 25 times 737. Okay. And the isotope abundance tells you how often each different isotope of an element is found. And remember, the 3 isotopes of hydrogen are protium and deuterium and tritium. The relative atomic mass is the average mass of all isotopes of an element. So we look at another example of calculating the relative atomic mass of a number of isotopes. So if we look at this element here, the element U comes in 3 different isotopes, so One of them has a mass number of 238 with a 50% abundance. One of them has a mass number of 235, that's a 20% abundance. And one of them has a mass number of 234, and that's a 30% abundance. So what we could do is we could do 50 times by the 238 plus 20 times by the 235 and 30 times by the 234. We add them together, divide by 100 to give us the relative atomic mass. So the answer to that in this example would be 236.2. Electrons have a fixed structure in atoms called shells or energy levels. These shells or energy levels go around the atom's nucleus. So electrons fill the atom's nucleus in order of increasing energy. The closer the shell is to the nucleus, the lower energy level it is. So the first shells to fill are the ones that are closest to the nucleus. An electron configuration tells us how an atom's electrons are organized. So the inner shells, the ones closest to the nucleus, can have a maximum of 2 electrons, and the next 2 shells can have a maximum of 8 electrons. So any extra electrons are then put in a 4th shell. So just to recap, electrons fill an atom's shells in order of increasing energy. The closer a shell to the nucleus, the lower its energy. So the first shell to fill are the ones that are closest to the nucleus. Electrons have a fixed position within atoms called shells or energies, which surround the nucleus. And if we want to calculate the relative atomic mass, we take the sum of the isotope abundance times by the isotope mass number, all divided by 100. And what tells us how an atom's electrons are organized? Well, that's the electron configuration. And the fixed positions of electrons within atoms are called electron shells.